Sorry, gentlemen, again back. I'm really sorry today. Just I'm not able to continue video. The signals break. I don't know the reason behind that, but signals are breaking. Start video just to 1 hour. It's surprising. The morning again that I'm not able to do it sufficiently yet. I'll try my best if I can do it. You can see that it's not simply that easy. I was talking of those type of that one. In this video is talking of something which is very important. That's heavy foundations, heavy objects, heavy machines, heavy foundations. You can say big size foundations with depth. We call heavy, massive blocks involved. You can say heavy foundations, big rafts, big machine foundations. But quantity must exceed 24 cubic meter. We just say concrete with thick elements and concrete with massive elements, massive block. When it is massive block, there's no limit of quantity. There's no limit means it can be in thousands of cubic meter, of course, depending on configuration, depending on design, how it works. Engineer is not easy to work in field. Civil engineer, who's actually, you can say, born engineer. If you don't have your soul dipped in engineering, if I don't have my soul dipped in engineering, I can't work. My soul is my power. Every person's soul is every person's power. If my power diminishes, I can't do anything. Very, you can say, important is this point. When we do heavy works, heavy foundations, our planning should also be heavy but based on analytical thinking. Analytical thinking means thinking where power of mind is used, where we understand exposure of problem, we study that problem, and each and every branch of that tree we try to understand. Engineering is engineering. It is indeed, we cannot run away from that. Engineering means we have to, you can say, we have to move fast. We have to move fast with good planning, not only planning but good of everything. We have to deliver. We cannot take everything for granted. And civil engineering in particular is such a field where speed matters, and if speed matters, quality also matters. This you can say event or this activity which is planned by this space you are looking at. This is only one activity, and that's part only. That is not even complete foundation, but only pour some foundation. Not for this, not for homework, it's not for steel fixing, it's not for something else. This proposal of this base is just an indicator how you can do. It's just guide, though it's based on complete thought, complete contemplation. What we have to do, keeping in mind what's happening on site or what would be happening, keeping in mind that situation, we evolve something like this, not only for this activity, for every such activity. Thoughts are important. If you are experienced, thoughts are very important. In fact, thoughts become, methods. Thoughts generate to methods, and methods to you know, methods to technologies. Usually people call it methodology, but I do not call it methodology. I simply call such writing, such pages, such thoughts in our own language, and that is, language like drawing. We, we create such pages for everybody, provided one reads. And that's what engineering is all about. To learn to do it best way. To learn to do something in ex- amount ex, exact what is exactly it is done, what you thought in your mind, that has to be done. And when I was asked to do this on some project, somebody asked me, give method statement, how should do? I was once just a little, shocked, because it's first time somebody asked me seriously, with seriousness, how you're going to pose this of this plan. Well, I did not got upset. I didn't get upset because I knew what does method statement mean, what did it mean that time. And I played my mind with my mind. My mind answered me something, and with that indicative answer I tried to solve that problem. And this is what says indicative writing, you can say, for some heavy foundation. Heavy foundation is very important part of civil engineering from design viewpoint as well as from executive viewpoint. Because first is that is money that can buy machines. If you want to do something, you write or you authorize a will. Okay, we come back to this and we have to understand this well. This heavy foundation everywhere requires to be planned properly and must be, because it is heavy concrete, maybe sometimes in many hundred cubic meters foundation. I still remember a case where I poured compressor foundation, that was cracking gas compressor foundation, which was 400 cubic meter. It's not small quantity. 400 cubic meter is not small quantity for one object, one element, or one machine. How much heat does it give? Can you calculate? Can you even imagine what does it evolve and what type of specifications we have to use in such foundations? That is, you may say, machine foundation, heavy machine foundation. Even in some building, you design raft for that building because of weak soil. You do not go to such extent of foundation. It may be a part of foundation of building or adjacent to that, but quantity is what? If you take ordinary footings, let us say 1 meter by 1 meter by 30 centimeters, or you can say 0.3 cubic meters, which is not big one. We cannot say this is threat, is a pollution contributory. You can't say that. But when you say 500 cubic meter or 400 cubic meter, it raises question mark. It's what we are doing? Question comes in. Why not to think separately so that we can not generate so much heat just in a couple of hours and put other sort of elements like trees in danger also, and put other lives into danger of long-term impact. It's very important that we have to work on such concretes which are reliable source for such foundations. This could be concrete based on, what I say. We can say PFA, that is Loris fly ash, or GGBS, ground granulated blast furnace slag cement, or microsilica based cement. These are often options we have in place of very pure cement, ordinary cement, because this fly ash based cement or GGBS based cement are what we have to provide. These materials we use PFA or GGBS. These are industrial products, industrial plants, bioproducts. Some comes from blast furnace slag, which is very useful for foundation industry. you as might have seen people people construct this life, and this is most important, otherwise where can you erect such a foundations? If we adopt such methods, into the requirement of safety, requirement of everything, that is of course included with this. You cannot go without that. Safety and quality. Of course, quantity. When we say safety first, this is you have to say it's very important to know what we can do, how can we do, and how can we sequence in such operations, such events of concrete pouring. I have already talked about preparatory works and temporary works, and I'm not going to repeat that. It's concrete pour, that's very important. Yes, some countries have been recorded very much. Those people have to think about, we have to think about how to do this. Very absolutely. Now, that's point we have to discuss. In last videos, I wanted to discuss that, but 2 videos have gone unnoticed, broken. This is third one. I started around 30. It's now around 5. So just in 1.5 hour, less than 1.5 hour. It's third video, and I don't know how long shall it work. Let me see. Let's hope it was faster. It depends on the system of our cube, of our quality. Issue is also not very strong. Keep our signals free. Now, when I'm talking of some concrete based, PFA based, or GGBS based, or microscrub based, I have to learn that first. I learned this in 1980. Yes. I was, involved in such detailing. Very important one. We have to conceive in how to prevent cracks. Cracks are imminent if you do not understand that foundation. Because quantity is very big, and concentration of area, height is big, length and width are considerably much or many times than what we do in even combined footings. We don't have that much size. And I'm saying 24-25 meters long and 10 meters wide and 2 meters deep. That very bad. Can we compute structures? That should be a point. Are we able to compute that qualitatively and quantitatively in our defined budget, which is based on project? These points must be considered, and these have to be done, even if budget doesn't mean anything, because we accept a responsibility on contract. Our site can show you clearly seen exact this status of question of quality and quantity. This is all observations and measurements issues. Again, it is gone, I think. I lost my video again, I think so. Yes, I think. Oh no, it's still there, I think. This is still working, I hope. Let me go to 5 minutes and come back. It's wrong. I'm doing something which is very much practical in engineering world. Means to plan something before doing that. That's what English says. Plan, do, check and act. Plan, do, check and act. This is what basics of engineering is in quality system. We have to plan, we have to do, we have to check and we have to investigate, so I know that. That's so criteria of quality system. If that quality misses, so we miss everything. Let me come back 5 minutes. Hold on there. Wait for a few minutes. Couple of minutes. We'll be back. think still it's on, maybe. So I continue with this talk. This is a foundation. Don't worry about title. This is a heavy foundation and it has about 400 cubic meters. If you think here, it is there may be much more, but it's very small size. But you can see this is 480 cubic meters. You can see here 480 cubic meter foundation, and this is plan how to pour it. You can see only pour plan, concrete pour plan, you can see. This is concrete foundation, concrete pour plan. Means it requires complete knowledge how you can do it. It's not simply that I at random do it. No, it's not that. You must have total vision about that procedure. If you don't have that, you can't plan that. If you don't have experience, you can't plan it. You see, quantities are given. You can see quantities approximately given. Thickness of strip is given. Depth of foundation is given, and strip width is given. Strip length is given. You see this 10 meters, I think 1 2 3 4 5, so whatever it is, means you can say it's given 12 meters, and this weight is 20 meters or more, possibly 1 2 3 4 5 1 2 3 4 5 10 20 meters by 10 meters. I'm taking it. You can invert its size, means the size doesn't matter here. It's only points more than 8 cubic meter is. It's more than 8 cubic meter thick. It's not thick given. It's not ordinary. It's neither ordinary nor thin and not thick element, but it's massive. Call it not mass. Believe me, it's not mass. Don't confuse yourself. I'm not talking of mass concrete. I'm talking massive block. Means a block which acts as a high quantity and high quality concrete it involves. High quality in the sense that you're not going to use ordinary cement for this. Ordinary cement doesn't work for such block, because there could be tremendous cracking if that is used, and because that ordinary cement is rapid setting, it cannot be called qualitatively suitable for such concrete quantity. Only this is giving procedure. It's not giving technicalities, but I'm just trying to share with you why it is done. If you have experience in concrete, if you have experience in construction of such foundations, with raft foundation, raft can't be set exactly what it is. It's more than 1 meter thick until, if more than 1 meter thick or 80 centimeter thick is more than 80 centimeter thick, we can say yes, fine, it is. It's actually a raft, you may say, a thick raft. The dimension, massive dimension, and it's okay, but it's machine foundation because design is also that way. It's not exactly what we design ordinary footings. It's a different kind, extraordinary footing. We say it's extraordinary footing. I'm talking of we have to control quantity, we have to control cement percentages, we have to control dimensions, and we have to control speed, we have to control temperature, we have to control shrinkage, we have to control curing. Means hardly some item, some provision, some requirements left. That's not controlled. Not only during pouring but also post-pour. You have to control this. In this case, what happens? Because quantity is much more than ordinary way. So I'll think of how to do it, how to push it for slow, for slow setting arrangement, not fast, not rapid setting. You want slow setting. Of course, it will take time, maybe considerable time to take, but time is a factor here. Factor is performance of this product, this massive block foundation. It should perform, it should set, it should harden within limits. And this should be done in low temperature mode, which is, you can say, as usual, normal temperature is 4 degrees or 5 degrees Celsius to 32 degrees Celsius according to standard specifications. That is for ordinary concrete. But we are saying this is not ordinary, this is extraordinary, you can say, because of its heavy standard, heavy status, and size is massive. Massive means it is going to, it's not, there's no expansion joint in this. That's an important point. A hole is one unit. There's not strips, as I'm saying strips, this is only for purpose of pouring. These strips are mentioned here in elevation or section 1 to 50. These are not for purpose of independent units. This is just for purpose of pouring in this mode. There's no shutters here. You can't say that these lines are shutters. No, there's no shutter. Just indication of number of layers we pour. And this quantity has mentioned 9.6 all in all these columns. This is also indicative. There's nothing as such. You can't even measure that after pour. And thickness also, you can say 40, 40, 400, 400. This is also laying thickness, not exactly metal thickness. No, it's not element. It's just a measurement of evaluation purpose, for planning purpose. And if this foundation is 12 meter, I'm saying, and this is 20 meters. These all strips only for indication purpose, not for measurement purpose. Nothing to do with that. So you can say in this case, if it is 10 parts here, and there are 5 parts here, so it's 50. That's what is important here, because shutters and this is where professional action we have to do. Only for purpose of pour. To allow any cold joint in various layers in concrete. Cold joints do not work properly. They do not allow to work concrete properly. There is no good bonding between concrete itself, and there is no uniformity. Some part is set, some part doesn't start setting, and other parts means that's complete confusion, ambiguity, maximum. We have to take that out from our minds. So this is what we plan, we do, we check, and we improve it. So it should be, in a way, we are going, layer by layer we go. It's just indicator. I'm saying you can change sequences of these numbers. There's no such hard and fast rule. But rule is that every layer in following layer, and then every other layer to come either horizontally or vertically with that layer. This should be hot jointed layers, because in concrete hot joints cannot be accepted. Hot joints actually are more important. Here, if you see, this is joint 1 and 2. They are abutting each other, so there is no question of cold joints. If you see, after laying 1 and 2, what to do? Then we say because 1 is earlier, it was laid earlier, so you put your layer onto this, so that layer 1 and layer 3 are hot concrete joints, hot concretes, like 1 and 2 was. But there was some gap between 1 and 2, and there was some more gap between 2 and 3. But still, we can say these 3 layers are reliable. When you say we completely do 3 and then why to do, then we say okay, 2 is recently done. So 1 and 2 are hot, and 2 and 4 must be hot. And then you say okay, then we do 4 to 5. Like that, you can say we are moving at an angular motion. If you say, if you consider angle, it's very low angle, which is really, which indicates that you're not standing, you're at an angle, and that's okay. This work, and that way you can see there are 50 numbers here, 1 to 50, and you can, they are in some sequence. If you see at, it's 31, and if you see on left corner down, it's 1 number, and on right corner top is 50. So 1 is at this corner and 51 at that corner top. And if you just go between, you see 38 and 14, then 10 and 42, you will find. So it's different types of counting. You see, you can't count like this. You see, vertically, if you say 1, 3, 7, 11, 20 to 25 to 15, 9, 5, 2, 4, 8, 13, 19, 28, which doesn't seem to be in consonance, but it is construction. Yeah, everything is done by experience, and that's a point. Now, if such, non-uniform mix or spread of layers indicate that there is no allowance for concrete to be cold, and if concrete is not cold, means generally all property as such remain ill connected. These are now cold joints removed and hot joints replaced. No question. But also we have to consider that this is physical work we are doing. We have to apply vibrator everywhere and interlink to previous one, at least vertically. And then for this we have to, what we have to do is say that we have to schedule steps as well. So start early morning or late evening in hot weather conditions. Thermal curing required. So it says 60 trucks, strips 8 cubic in each. Frequency is 15 minutes, and thermal curing required is, of course, and 2 pumps are required. 60 trips total. This step planning can be done for whatever foundations do you have, and not only massive block, you can do for other items also. If you feel, you have to show where pumps will be located, where trucks will stand, what is your access to site, and how steps shall be poured, how you have managed steps. You must be ready with answers if somebody raises question. After all, this is public. Yes. Point here is, how can we monitor this. Pumps can be any number, that's up to you to organize with vendor. But procedure is not very. You can plan whatever size with this method. Only you have to do is temperature controls. That's most important point. Not more than 24 degrees. Not more than that. And you have to provide differential thermometers in whole that and at various connections. You have to do differential thermometers. To improve durability of concrete, to improve its internal properties, to decrease its setting time, and to decrease the formation of cracks, to increase durability, to use various other methods for its production. This purpose statement is very useful if viewers can understand this. It's not poetry or a sermon. Exactly. We have to now understand this very well, that you can provide differential thermometers in this for rising, falling temperatures records, and we can also observe them for weeks during pouring and post pour of hardened concrete when this remains in order. We are using GGBS in this because of suitability of GGBS much more than OPC, SRC or PFA. GGBS, that's ground, glass, you can say blast furnace slag cement, that can be replaced up to 80% even of cement mass. PFA is also useful, but PFA is inferior to GBSA, that 25% maximum limit allowed on GFA does not give any direct results. So, so what? Well, it will delay in this because of the reason the problem is they have to bear with me because of some reasons. It's lucky that it starts working and we have to have differential measurements and plot that readings around clock for during pouring and then during curing all times same frequency and the rate of the rising falling temperatures. It's a gradient that comes from beginning of giving same till temperature change. Yes, stop here. We have to understand this differential thermal moment should not induce any cracking in this. That point we have to be sure of. This procedure where it is in from top portion, middle portion, and down. You can say no cracks, shrinkage works, and we can see that professionally we have to do. Then not only pouring, we can do pouring in the sequence. Also, you have to see that curing. Curing is much important. It may take, you can say, if you start layer number 1 and you go to layer number 50, it may take maybe 5 hours or time depending on 15 minutes interval. If you say 15 minutes interval, then in 1 hour there are four transit mixes delivered. This will see how place two places of pumps. This 8 transit mixes. 8 transit mixes are in 4 hours. 8. This means 50 about 6 times, and you can say 15 minutes and 15 minutes. So 60, 50 transit mixes you deliver. So 50 means 25. 25, 15, this is 6 hours, you can say. 6 hours pour maximum. 6 hours you have starting temperature, starting layer 1 and end layer 25, and 6 hours are quite good from the receiving point. Also, there should be in the beginning of this work, I wrote this statement. Layers were fine, but only question was raised about curing, which I could not satisfy in the beginning. And later we changed the whole system and redid that inside. That was accepted as a thermal curing from top and around. Thermal curing, as I confirmed video in the beginning, thermal curing we did means heat evolution due to reaction was not allowed to escape. That heat we had to digest, we had to absorb heat of concrete due to chemical actions. This energy should not go into weather, and this was the purpose of thermal curing. Concept was that when curing is done in ordinary way and when concrete is done in extraordinary way. This is second class extraordinary way. Right? Yes. Everything, one must produce first method statement. If you have done, what's your statement? Do you write something or you just tell, I'm doing this, I did this? Does you record? That you directed out what to do? Now there's nothing. Concept was not available that time. The concrete can be cured by thermal energy. Only water concept was contemplated, but basics of curing was not clear. What we learned in add water, use water for curing, and that was only concept. But you think something that even heat is a concept. If heat is in the limits of 32 to 40, agitators of the 40 areas, and then take this as into tuition. I do it as a and we converted ourselves into very high profile officers producing nothing but ordinary concrete now. It's different concrete. It's you can say thermal concrete, you can say thermally controlled concrete for purpose of high profile foundations, and also use of GGPS up to 70% of cement replacement, OPC replacement. That's a good combination. We can also use microsilica in this, which is up to 9%. Microsilica is a little expensive, but there's no part to use. So we can use for replacement GBS and also for PPS, that's 20%. This is harm in test of person. We can take thermal readings, differential gradings, thermal gradings, what's value at top and what's value inside heat is generated with whatever cement you have. That heat increases temperatures and that should be the limit 70 degrees difference. So it's a criteria in specification I talked last time. We will study again on time how it works so that it's a little efficient. This is only way that we can continue with this. And when you, as I said, thermal curing, you may ask what is thermal curing. Maybe many of you did not listen last time. It's very simple. All four sides are covered up with formwork. Only top is not covered with formwork. Rather, there are so many other inserts. You can say those. You have to observe them, but you have to cover that surface by some method, that is material which thermally insulates it from weather or bottom vertical sides, and we have to place some isolation layer on that. You may say Hessian bag or something, so that covers are also different. So might have seen original book or old version book and new version book. Some writer. Now if you closed from top that surface, no heat should go out. Heat should remain within the body of concrete, because vertical sides are all closed and horizontal sides are closed. There is several signs. There is no way that you can damage this concrete by GGBS. It will improve quality of concrete. Temperature control shall improve quality of concrete. Moreover, thermal curing is best one, that heat is not allowed to go out. And we try to pour water on sides, vertical sides, from any of so we did professionally. It's interesting to note such things as issues. We can say that I should not now move further. If you go further, you will find, that this is what you saw about with this talk of. We can say this is foundation we talked of. So what we said in generator foundation, let us say generator foundation, we actually said this was something. It's important activity of pouring curing. So it says this pours be massive concrete block, coordinate, make sure that coordinated instructions being issued. All we have to do temperatures, elements, etc. We have to go through that. Fair face concrete is also very important part. Fair face concrete, that all items should be made for various vertical members as described in in earlier described earlier, and ensure that plumb doesn't exceed out of line is 1 millimeter and 1000 mm. No opening of sides allowed in fair face. No opening of sides allowed. And you can say unrequired joints aren't allowed. Make sure all supports are well anchored. Make proper concreting pouring arrangements. During concreting, no wides or honeycombing are acceptable. This very important point, no wides also, because these wides can only do Now, you see that no unrequired joints are allowed. No opening on sides allowed for face formwork, and supports are well anchored. Make proper concreting pouring arrangements. Then make sure all supports are well anchored. Make proper concreting pouring arrangements. Then during coring concreting, no voids or honeycombing are acceptable. Then make proper pouring plan for walls as far as fair face generally of purpose for this way we can say fair face is that surface where no plaster is applied, whatever texture is required, whatever face is required, no repairs, just complete concrete smooth surface. I did this on Record Center. You can say that concrete would be poured in layers of uniform thickness, allowing no seam curve surface. No honeycomb will be accepted in fair face. Concrete should be pourable. Consistency using plasticizer. Better if self-leveling concrete is applicable and allows very expensive. Over-vibration has to be avoided. Drop height of pumps to be maintained. Then high level of supervision is required. Pouring gang has to be trained for such type of elevation structural works. During preparatory works, form oil must be applied on day to now curing has to follow as specified, and during pouring the lines and drum have to be kept in monitoring constantly and bulging stains should be recovered immediately. Architectural finish is some kind of pattern form surface, and that pattern is repetitive. And this is what is a very important point in this, especially like separately. So the money they goes to people. If we can do that successfully, I think we can do it. So this is architectural finish, same except pattern on surface of both sides, surface of both side elevations. Some kind of architecture we have to do. The plank surface or some of the surface. Generally planks used because planks are rough and made completely joints free, no leakage is accepted. It's a difficult job, but what to do? I have to do. difficult or not difficult, we are supposed to do, no way in. So these are quality, holy slab, and before holy slab might have this wires in block, different shape of block, trapezoidal. As we discussed last time, of holy, this thing also discussed. No, it is completely different word here. We deal with hoodie. How do you call it? H-O-U-R-D-Y. Howdy. In this beams to exist that are seen and not seen. Soffit is one level, plain soffit, and plaster is the, because of different materials. You see hoodie surface, then you see plain surface. Holy block is rough, of course, it's concrete block, and plastering is easy, formwork is easy, because no drop beams in this. When beams are formed in hoodie on the site itself, tapered portion of block, which higher size is above, lower size is down, and then spacings of blocks, narrow spacing, and then cross spacings, because they both the terms, both sides. We have to create a network of system, and this hollow cavities of hoodie in both directions consume areas for services, while in space 6 we have to fill concrete in. Thickness of slab excluding this hoodie is 60 centimeters, 60 mm generally, maybe more, but very thin is this. In this we will place in everything. When you can say, it's to be noted that slab is too thin, say 60 mm. Therefore, services embeds in, not embeds in. Maybe number find any room. You cannot find any room through or within slab portion. The bigger area of hoodie slab should be planned to pour since thickness is relatively lesser. All top levels are well earmarked and are clear of concrete spaces and positions. Rebarred touch paint is continuously applied, it's epoxy coated. Whole portion to receive concrete is clean. No dirt is seen in beams fitted hardy. Damaged blocks are replaced well. You can't use damaged blocks in this. Then make sure again formwork supporting system is intact. Ordering or concrete using pump and check all arrangements for pouring are available. Plant operator should be instructed correctly about requirements. Make ready available concrete curing arrangement. Make sure for MS concrete, excellent vibration shall be applied. That's the MS means microsilica concrete. Excellent vibration shall be applied. In certain cases, setting time will start delayed by many hours. Receive concrete after site testing and start from one corner of beams, and suggested that pour beam first follow thin slab. Use wooden timber floor to finish unformed surfaces. Adopt curing procedure immediately after finishing it, depending on weather conditions. And they'll see other oil will take up later. Now we'll take all these later on. It's all important, but we'll take later on. And this, sequence which he did to take into consideration all this, because we'll take this sloping portion later on, and also we'll take heavy compression pour, tabletop concrete pour, slab pour will do, swimming pools will do. We'll do a lot of this later. So meanwhile, I'm going to close this now because it was thought of to do it faster, but my backing is not I should say boring is very important activity, because I've seen such rubbish borings. I've seen very bad posts. I've seen photos on Facebook and others. Really, I feel sometimes you burn yourself looking at such results. Results which is not digestible. As an engineer, you cannot digest such bad acts, bad works, not acceptable to anybody. It's not that I or you or someone else. You burn sometimes yourself seeing such acts. Really, that's worrisome. It happens, but only way is to improve. And if we can't improve, what can be said about that? If we can't improve, what to do? Improvement is improvement. If we don't improve, who shall improve? It's engineering work. Only engineers should think how to improve quality so that designs are properly delivered. Relation between design team and concreting team is very strong. As I usually say, design may be excellent, but if it's not properly implemented, it doesn't have any meaning. It doesn't have any meaning because designer does everything. Design engineer takes into considerations all requirements of code, of client, of project, and then tries to find solution, delivery solution, and that's further refined, and then further refined, and reach to precast covers, pre-stress covers. Those points are very well understood, must be. And if you say no, I think that won't work. I have to be very clear about this issue. It's not an issue alone, it's requirement, we can say. It's requirement. If we cannot meet such requirements, what for we are in field, I would suggest field engineers to be submissive to quality requirements and specifications, read them, understand them, and then only we can say we can achieve something. Not only this method, all other methods, all other items must be taken care of, and if we do not, we cannot achieve our goal. That point is extremely important. We have to be curative. We have to be controllers and not just leave it to itself. And later on cry, this has happened. No conflict can be palliated. Worst, if engineers are best. If engineers are careless, they do not care for job, they do not care for activities, they will hide. Hiding is not easy. Hiding even after you finish, plaster on that. Somebody would say here's a problem. That is what is engineering about. Expertise, experience, knowledge, theoretical, professional, everywhere. Engineering pays, it pays and pays. And this message, I would say, exclusively we require mechanism for every pore. We have to think even maybe small pore or maybe small design. If we think, if designers think, I can give method, statement, I think there's no harm if I write brief on some drawing what we have to pour it. Because seniors you are, or whoever are seniors, they can write in some form for those people who have not high degree of knowledge. They must benefit by your experience. That's very important. And I think we understand what we have to do. With this, I think I should close this one today. Thank you very much, gentlemen. Okay, we'll see you later on.